So what we're going to do in this video is prove a relatively simple fact about vector spaces. So we want to prove that the additive inverse of the additive inverse of V is equal to V for every V in the vector space capital V. In other words, we want to prove that negative of negative V is equal to V. This might sound like something that's so ingrained in us that we do it for real numbers, like we say that negative 9 is equal to plus 9. But it's something that we can actually prove rigorously. So we're gonna prove that for vector spaces. So we're going to say, suppose V is in V. So suppose V is a vector space. Sorry, suppose V is a vector in the vector space, or V is an element of V. Then uh, we have, let's start with negative V on the left hand side. So sorry, let's start with negative of negative V on the left hand side, because we want to prove that it's equal to something else, which is in this case happens to be V. So we want to attempt to, by chain of equalities, arrive at expression 1, expression 2, expression 3, then somewhere down the line maybe arrive at our desired result using a chain of equalities. So let's see if we can do that. So let's start with negative of negative V is equal to, well, by one of the axioms of a vector space, we know that we can write this as negative of negative V plus 0, where 0 is the 0 vector. And we can write this as negative of negative V plus negative V plus V, because 0 can be written as a vector and its additive inverse. And obviously V plus negative V is equal to 0, and since vector addition is commutative, we have negative V plus V is equal to V plus V plus negative V is equal to 0. So that works. So now we have negative of negative V plus the quantity negative V plus V is equal to the left hand side that we already had. Now let's use the another property of a vector space. We know that addition is associative. So we're going to rewrite this as negative of negative V plus negative V plus V. Now if you notice, negative of negative V is clearly the additive inverse of negative V. So a vector added with its additive inverse is obviously going to be 0. So this becomes 0 plus V. And you can see where this is going. This becomes V, which is exactly what is desired. So we have proved this. There we go.